Here's a quick example on some simple probability questions and how to solve them using the dash technique and also a calculator. Okay, so we've got a typical type of question. We see these all the time where they talk about some form of a lottery, or I don't know, degenerate gamblers always come up with these probability questions. In this case, you've got a lottery that has numbers from 1 to 40, and you have to pick 5 of them, right, in any order. And order doesn't matter. If the numbers come up 1, 2, 3, 4, 5, and you had picked 5, 4, 3, 2, 1, you would still win the lottery. And then they have this second kind of game that they're going to talk about where you select 5 digits from the, a regular digit just being from 0 to 9, but those have to actually be in the precise order. And then the last part talks about making it a fair game, which is another way of saying that everybody breaks even, there's no profit. Okay, so I've already worked them out. You can see the answers there. And then let me show you how we get those answers. So we'll start with A. So in this lottery game, the jackpot is won by selecting these 5 different whole numbers from 1 through 40, and you get the same 5 numbers in any order that are drawn later. What's the probability of winning the jackpot in this game? Well, you have to ask yourself, how many different sets of 5 numbers are there? And then in order for you to win, you have to have one of those sets, right? So if you think about it with the dash technique, you have to choose 5 numbers. So there are my 5 dashes. And you have the numbers 1 through 40, and it's a typical lottery, which means you can't choose numbers over and over again, right? So you have 40 choices for the first one, and then 39, 38, right? 37, oops, and 36. But order doesn't matter, right? In any order. So that means, again, if you chose 1, 2, 3, 4, 5 as your 5 lottery numbers, or if you chose 5, 4, 3, 2, 1, that's considered the same pick, right? It's the same 5 numbers. So when order doesn't matter, we're not done, right? If order matters, this is it. This is how many ways we can choose 5 items out of 40 total items where order matters. This counts all the different permutations. But we don't want to count all those permutations as being different because order doesn't matter. And so then you have to ask yourself, okay, how many ways can I rearrange 5 things? Well, I have 5 choices for the first thing, and then 4, and then 3, and then 2, and then 1. And if I divide by this number, that divides out all of those permutations, and this ends up giving me the total number of 5 number groups, right, where order doesn't matter. Now, if you want to do it with formulas or you want to do it with technology, it's a combination. It's a 40 choose 5 combination. Okay? Now, with technology, we all have our fancy little graphing calculators. Even if we don't have a real one, we can have these free little emulators. To do the combinations or permutations in the emulators, you have to give it the first number, so that's the 40. Then you hit math, and you want to go over here to where it says probability. So you arrow over to probability, and you'll see there's your permutation, there's your combination, there's your factorial. Those are the 3 that you would be using for these types of questions. We want a combination, and then all we have to do is give it the second number, which is the 5, hit enter, and there's the 658008. You can see I put right here. Now, why did I answer 1 over that? Well, your probability of winning is having the one, right, correct combination of numbers divided by all possible combinations of numbers. Now, I know you're thinking, yeah, but if I bought a ticket that was 1, 2, 3, 4, 5, or if I bought a ticket that was 5, 4, 3, 2, 1, those would both win. So don't I really, in theory, have more than one winning ticket, possible to buy? So it's really not 1 over 658008? Well, yes and no. See, when you're doing probability, if order matters, then you have to let order matter for every step. If order doesn't matter, then you can't let it matter for every step as well. And because in this case order doesn't matter, and we're not going to count every different type type of ordering of those 5 numbers as being a different possible lottery outcome, then you can't count them as different possible lottery tickets for you to buy. Okay, now if you did want to think of it as all possible lottery tickets, then you would just not do the bottoms and you would instead just do the top. And then that's all possible 5 number combinations where order does matter, and you go, okay, those are all the different possible lottery tickets that you could buy, right? That, because that allows you to buy them in any order. But you do know that if you go to buy a lottery ticket and you give them 5 numbers in any order, it's just going to come out in numerical order. And then if somebody goes and asks for the same 5 numbers and gives it to the clerk in a different order, it's still going to print out just in numerical order from smallest to biggest. So in reality, there really are only this many possible lottery tickets. If you did it with this number, then you would have to say that you have this many possible tickets you could buy, because those are all the different ways that you could buy the 5 numbers in any order. I think that's more confusing. So just remember that when order doesn't matter, it's a combination. We're going to do a combination. This whole thing, both colors, right, is where we get a combination. It gives us the 658008. That's the total number of sets of 5 numbers, and there's only one way to win, right? One set that wins. So that's why it's 1 over that. Part B. Here again, picking 5 numbers. All right, but in this case, repetition is allowed. You have from 0 to 9 to choose from, so 10 choices. And you have to get the same 5 numbers in the exact order, so order does matter, and they want to know what's the probability of winning this game. So that means when you pick your numbers, you only have one good choice for the first number out of 10 total choices. And then you have 1 out of 10 for the next one, and 1 out of 10 for the next, and 1 out of 10 for the next, and 1 out of 10 for the last one. Because you can choose the same number over and over again, so that's why you have 10 choices for each, 10 total choices. And because you have to match the exact number in the exact order, you only have one choice for each of those spots. When you multiply those all together, that's how you get that probability. Okay, so now this, how much money do they have to pay us in order to break even? Well, if you have a 1 out of 100,000 chance of winning this lottery, then that means if you played it, in theory, if you played it 100,000 times, you would win once and you would lose 99,999 times, right? Because those add up to all 100,000. When you lose $1 each time. They told you pay $1 for a ticket. So that means you've lost this much money. When you win, they have to pay you enough money to win back all of your losses plus the $1 paid to play. A lot of people would think that this number here should be 99,999, because I would win the 99,999 and then I would lose the 99,999 and I would break even. But you forget that if they paid you 99,999, you actually only won 99,998 because you paid $1 to play. So that's why they would have to pay you the full 100 grand, and then you would subtract the $1 fee, so to speak, to play the game, and you'd be left with your 99,999 as profit, and then therefore break even. Okay, that's how to tackle these types of probability questions with the dash technique and a little bit with the calculator as well.